Students, we are given this question to find the argument and modulus of this complex number. Now you have to know another word for argument is amplitude, okay, and another word for modulus is absolute value. So just for the sake of information, now we are given z to be equal to 1 positive 0 I. So that means if I were to write this in form of x positive iy, clearly x is going to be equal to 1 and y is going to be equal to 0. So therefore the absolute value of the complex number, which is given by the formula x squared positive y squared, is going to be equal to root of 1 squared positive 0 squared, which is equal to root of 1 squared, which is equal to 1. So this is the value for the modulus. So you can write it down. So modulus of the complex number is equal to 1. And now we are expected to find the argument. Now the argument of the complex number z is given by, actually we have a formula that's going to be tan inverse of y divided by x. Now this is going to be equal to tan inverse of, my y is 0 but my x is 1, so this is going to be tan inverse of 0. Now we have to find for what value that tan inverse of 0 is giving us, but clearly we know that it is going to be in the first quadrant. Okay, so this is going to be in the first quadrant. Now clearly we know that tan inverse of 0 is going to be equal to 0. Now if I were to take the representation for the complex number, so this is going to be my real axis and this is my imaginary axis, and clearly the value argument of z is equal to 0 will be in the first quadrant. Okay, now you should also know that the principal values are distributed as follows. So this is going to be negative 1 and positive 1 and positive I and negative I. So this is the way in which the principal values of a complex number is distributed. Okay, so having obtained the argument of the complex number to be as 0, let us use the formula. We have got argument of z which satisfies the relation for theta. Okay, theta should be between negative pi and positive pi. So the argument of that complex number, which is in satisfaction with this theta lying between negative pi and pi, is given by the formula argument of z positive 2n pi. Okay, so this is a very important formula that you have to know. So from this formula, argument of z is 0, that has to be added with 2n pi, and that would give us the required argument for the complex number, which in this case is 2n pi. So the solution is obtained in this fashion. Students, let us now do the next question. Say you are given the complex number z to be equal to I. Okay, so in the first case I have obtained the complex number z and its representation would be on this point. Okay, just to make it a little bit more clear. Okay, coming back to the complex number z is equal to I. Now this is actually z is equal to 0x positive I times y. So y is equal to 1 here. Okay, so from here clearly I know that x is equal to 0 and y is equal to 1. Now if I were to find the modulus of this complex number, this is going to be 0 squared positive 1 squared, which is root of 1 squared, which is equal to 1. So the complex number's modulus is 1. Now we are expected to find the argument of this complex number, ARG, capital ARG, which in this case is going to be tan inverse of y divided by x. And that is going to be tan inverse of, my y is 1 but my x is actually 0. So we have a quantity like this, right? So 1 over 0 is going to be undefined or infinity. So for this, clearly we know this is only possible when we have the angle to be as pi over 2. Okay, because if I were to take tan inverse of 1 over 0, it's nothing but sine inverse of 1 over 0 divided by cos inverse of 1 over 0, and we know the value as pi over 2. So in this case, the argument of z is pi over 2. Now if you were to represent pi over 2, that this is 0, I have already made the representation for z is equal to 1 here. Now for pi over 2, this is exactly hits at this particular point, which in this case z is equal to I. So this will be 90 degrees. Okay, so I have that in mind. So these 2 points can be connected. Okay, so initially I started with just a point. Now I'm able to get the first quadrant. Now this is actually not complete, because we are expected to find that value of theta which is satisfying the interval negative pi to pi, and that is given by the formula argument of z is equal to capital argument of z positive 2n pi. Okay, so now the utmost property or utmost solution that we have here is to finalize what happens to this. So the final answer in this case is going to be pi over 2 positive 2n pi. This is my argument of z. So this is the final answer to the given question. Students, we are given the third question. What if z equal to negative 1? Okay, so in this case, if I were to rewrite this as a complex number, x positive iy, then clearly from here x will be equal to negative 1 and y will be equal to 0. Therefore, the modulus of the complex number is going to be negative 1 raised to the power 2 positive 0 squared, which is equal to root of negative 1 squared is going to be 1. Root of 1 will give you 1. Now, having obtained the modulus, let us obtain the argument of the complex number, which is tan inverse of y divided by x, which is equal to tan inverse of 0 divided by negative 1, which is clearly, in this case, we have to be a little bit cautious in obtaining the value for argument of z. Of course, you cannot simply write, or you cannot simply place 0 here because of the complex number being z equal to negative 1, because it is not only that 0 is produced on the right side of the positive axis, or in other words right side of the axis for the real axis, okay, but 0 is also produced on the left side. Okay, this is also the other side of the real axis. Okay, but the only thing is that this part is negative side. So in this case, the 0, we can't just place here 0, but we should place here pi, because arctan or tan inverse of pi will also produce as a 0, but in that case the complex number that we need is z equal to negative 1. So that's the reason I'm placing the required point should be on this side of the axis, not on the right side, on the left side, where I am able to have z to be as negative 1. So having got this point, I can very well connect this with the point z equal to I. Thereby, I'm able to get the first quadrant and the second quadrant. But this is not complete. We are expected to find argument of z, which has a formula, argument of z positive 2n pi. But this is already pi. You place the pi and you add it with 2n pi, thereby giving us argument of z. This is the answer to this complex number z equal to negative 1. So students, you got the final complex number z being equal to negative I. Now clearly, if I were to write this of this form x positive iy, then x will be equal to 0 and y will be equal to negative 1. So therefore the modulus of z is going to be square root of 0 squared plus negative 1 raised to the power 2, which is going to be root of 1, which is equal to 1. So the complex numbers modulus is equal to 1. Now what we got to do, we got to find the argument of the complex number, which in this case is tan inverse of y divided by x, which is equal to tan inverse of the coefficient, or in other words, the quantity of y is -1, quantity of x is 0. So this is going to be tan inverse of -1 divided by 0. Of course, z is equal to -I. On the representation, we are going to be having it on the other part of the imaginary axis. So that's going to be over here. Now, this is only possible, see, when we have the argument of z to be equal to -pi/2. Okay, so in the former case, for the positive side, we got z to be equal to pi/2 with the positive sign. That is because the point, the complex number given to us was z is equal to I. So it's the reason that we have obtained the argument of z to be as pi/2. But in this case, the complex number z is equal to -I. So if we were to use the unit circle to locate the point, then the argument of z will be -pi/2. So we can connect these points, and thereby we get a beautiful circle with the real axis stretching from -1 to 1 and the imaginary axis stretching from -I to I. So now let us complete this question off. So this is going to be equal to -pi divided by 2. So therefore the required argument for the given complex number is going to be equal to 2n pi adding the -pi/2, and you can rewrite it as 2n pi -pi/2, which would conclude this question with this solution. Of course, n is element of integers. Students, we are given this question. We are expected to plot this complex number z is equal to 5 times of cos pi/4 positive I times sine pi/4. Now we know that any complex number can be written in the form x positive iy. So I am going to place x positive iy to be equal to 5 of cos pi/4 positive I times sine pi/4. Now after I have done this, if I were to equate every complex number on the left to the right, then this is the standard way. X is going to be equal to r times cos theta, and y is going to be equal to r times sine theta. Have that in mind. Very important formula that is used to connect the Cartesian coordinate with the polar coordinate. Now from the above we can write, therefore we can say x is equal to 5 times cos pi/4 and y is equal to 5 times sine pi/4. Now this is equal to 5 times cos pi/4 is going to be cos 45. Similarly, sine pi/4 is going to be sine 45. Now over here it's going to be 5 times sine 45 and cos 45 are one and the same. That's going to be 1 over root 2 for x, and for y it's also going to be sine 45 is going to be 1 over root 2. So we have got this to be as 5 over root 2. Also for x we have got 5 over root 2. So therefore the required complex number, which we have taken z to be as x positive iy, is 5 over root 2 positive I times 5 over root 2. So if you see here, both these values of x and y are positive. So if you were to draw the Argan diagram, the real axis and the imaginary axis, the values for x and y are positive. So that means they are going to be in the very first quadrant, and in this quadrant my theta is going to be my alpha. Have that in mind. So the alpha value which is given to be here is pi over 4. So therefore, if you were to plot the complex number, the magnitude of the complex number is 5 units. So if I were to start here, 1, 2, 3, 4 and 5, so just go up here and draw the complex number connecting with the origin. So this complex number can be represented as z to be equal to, I can either write the entire form of the complex number like this, or simply write the magnitude and follow it up as cis. This is the abbreviation you have to know, CIS, and the alpha value, which is pi over 4. So this is the way in which you have to represent the complex number, and finding the complex number and finding the amplitude by using the principles which I've taught you, and the magnitude. So that completes the solution for this question. Students, we are expected to plot this complex number z equal to 4 times cos of 2 pi over 3 positive I times sine of 2 pi over 3. Now foremost, what I would do is I would consider the complex number to be of the form x positive iy, and then I would equate the complex number to x is equal to r times cos theta and y is equal to r times sine theta. Clearly from here I get x is equal to 4 times cos 2 pi over 3 and y is equal to 4 times sine 2 pi over 3. Now this is going to be 4 times cos of 120 degrees, and this is going to be y is equal to 4 times sine of 120 degrees. Okay, so now we need to know what is cos of 120. Now if you were to use the unit circle, okay, this is the unit circle, this is 90, this is 0, this is 180, 270 and 360. 120, okay, 120 is featuring somewhere over here. Now we know this is all silver teacups, okay, that means all ratios are possible, sine alone is positive, tan is positive, and cosine and its reciprocals are positive here. So sine, in other words cos 120 in this case is going to be negative. So that is going to be, the value would be negative 1 over 2 for cosine and positive root 3 over 2. So x is going to be 4 times of negative 1 over 2 and y is going to be 4 times of positive root 3 over 2. So this would give me 2 times root 3 for y, and this would give me negative 2. So therefore the required complex number, which is assumed to be as x positive iy, is now going to be negative 2 positive 2 times root 3. So if we are going to be considering the Argan diagram, this is the Argand diagram, this is my real axis, this is my imaginary axis. Negative 2 is coming on the left side, okay, of the real axis, in other words the left side of this axis, that's going to be here, negative side, and positive 2 times root 3 is going to be on this side. So this is the positive part of the imaginary axis. So the magnitude is given to be as 4, so we have to take 4 units, okay, 4 units from the origin O, and if I were to draw the line, so it's going to be somewhere over here. But the most important point is, this is alpha. Alpha is located on this side, so that means it is present on the second quadrant. So then my theta is going to be pi minus alpha. That is very crucial, have that in mind. So this is going to be 180 minus my alpha value, which I need to place there. So if I were to represent this complex number on the Argand diagram, this is the real axis, this is the imaginary axis. Negative 2 will fall on the negative side, okay, and positive 2 times root 3 will be somewhere over here. But the magnitude of this particular complex number is given to be as 4. So take up 4 units from the origin, and that would be somewhere over there, and you can represent the complex number by this fashion: 4 times cis of 2 pi over 3. So the theta would be stretching from this end, okay, and that completes the solution for this particular question. Students were given the next question. We are expected to plot this particular complex number on the Argand plane. So let us consider the complex number z to be of the form x positive iy, and then we know that x is equal to r times cos theta and y is equal to r times sin theta. So from here I've got x to be equal to 3 times cos of negative 5 pi divided by 6, and y is 3 times sine of negative 5 pi divided by 6. This is what I've got. Now this is nothing but 3 times cos of, so this is going to be 3 times cos of negative 150, and y is equal to 3 times sine of negative 150. Now cos is an even function, so this can be written as 3 times cos of 150, and sine is an odd function, so I write it as negative 3 times sine of 150. Now 3 times cos 150. Now cos 150, if you were to take the unit circle, cos 150 would be somewhere around this region, because this is going to be 90, this is going to be 180, so cos 150 would be between 90 and 180. Now cos of 150 is given to be as negative root 3 over 2, okay, and sine of 150 is going to be positive 1 over 2, so have that in mind. So this would give me x to be as negative 3 times root 3 over 2. This would give me y to be as negative 3 over 2. So I've got these two values. So therefore the required complex number is going to be 3 times root of 3 over 2 positive I times negative 3 over 2. Okay, now if you were to use the Argan diagram to represent the complex number, then you will see that the x-axis is featuring on the left side of the real axis, okay, or I would say real part of the imaginary, or I would say real part of the complex number. So it's featuring on this side, okay, on the left side, and also the y part is featuring on the negative side of the imaginary axis, okay, on this side. So the theta, or in other words the angle given to us, is 5 pi over 6 with the negative sign. So if you were to use the modulus, which is 3 units, and draw, it would be negative 1, negative 2, negative 3, okay, 3 units. You don't need to be negative or positive, but because of the negativeness of the x-axis, or in other words x coordinate, and the negative nature of the y coordinate, I'm moving 3 units, okay, so that is going to be somewhere over here. So if this is the origin, so you will have to connect the complex number stretching 3 units, but this is, you need to plot this point, okay, so this one would be approximately, if I were to use the calculator, 3 times negative 3 times of root 3, that would going to be, so the representation for this complex number would be on the 3rd quadrant, okay, so you can very well write it as 3 times cis of negative 5 pi divided by 6. So this is the representation of this complex number, and the theta will be measured from this direction. So this is going to be my theta. So have that in mind. And that completes the result for this question. Students, let us represent this complex number. As usual, I would be taking x to be as r times cos theta and y to be as r times sin theta. So clearly this is going to be x is equal to 2 times cos pi over 6 and y is equal to negative 2 times sin pi over 6. So this is going to be 2 times cos 180 by 60, that's going to be 30 degrees here, and in this case negative 2 times sin 30. So this is equal to 2 times cos 30 is root 3 over 2 and sin 30 is 1 over 2. So I am getting y to be as negative 1, and in this case x will be root 3. So if I were to write this complex number, so x is going to be root of 3, okay, negative 1, so that's going to be negative I there. So the Argan diagram, if you were to be drawing it, this is the real part of the complex number, imaginary part of the complex number. Root 3 will be occurring somewhere on the positive side, but negative I would be occurring on the other side of the imaginary axis. That means it will be down below. Now the theta, or in other words the pi value given to us is, in other words the angle given to us is pi over 6. So that means my presence of this complex number would be somewhere over here. So just stretch for 2 units. Okay, I'm stretching for 2 units. If this is 1 and this is 2, stretch for 2 units, okay, from the origin. So this is 2 units. So this is going to be 2 times cis of pi over 6, okay, because this is the ideal representation given the fact that the complex number, in fact I should write this as z, okay. So z is equal to root of 3 negative I. Because of this nature, my presence or my complex number is located on the 4th quadrant. So that completes the solution for this question. Students, we are given this question. We are expected to find the modulus and the principal argument. So the key word is principal argument. Have it in mind. For this complex number, z to be equal to root of 3 positive I. Now you write down the formula. We know that if z is equal to x positive iy, then modulus of z is equal to root of x squared positive y squared. This is the formula we know. So therefore modulus of z is equal to modulus of the complex number root of 3 positive I, which is equal to root of square this root of 3, and to it you add the square of the imaginary part. This is going to give us root of 3 positive 1, which is equal to root of 4, which is equal to 2. You only take the positive side of the modulus. So therefore you can write it down that mod of z is equal to 2. So this is fine. Now from here we know that clearly we know that x is equal to root of 3 and y is equal to 1. So therefore alpha, we are not finding theta because theta is a principal argument. We can only find alpha from this complex number. So alpha is equal to tan inverse of y divided by x, which is equal to tan inverse of 1 over root 3. Now this value we know to be as pi over 6. So alpha is equal to pi over 6. So if you were to plot the alpha, alpha would be in the first quadrant. Okay. Now since alpha is in the first quadrant, we know that theta is equal to alpha. This is the imaginary part. So therefore the principal argument is pi over 6 and the modulus is given to be as 2, And that completes the solution for this question. Students, we are given this next question. We are expected to find the modulus and the principal argument for this. So therefore clearly mod of z is going to be root of negative root of 3 raised to the power 2 positive 1 raised to the power 2. This is equal to root of negative root 3 squared will give me 3 added with 1, which is going to be root of 4, which is going to be equal to 2. So modulus of z is equal to 2. Now clearly we also see that you can write it down here. Also x is equal to negative root 3 and we have y to be equal to 1. So alpha is tan inverse of y over x, which is equal to tan inverse of my y is 1 but my x is negative root of 3. So this means if you were to draw the Argan diagram, this is real axis, imaginary axis, the negative root 3 would be present on the negative part of this axis. So it's going to be on this side. Now since the modulus or the amplitude is 2 units, you can stretch 2 units from the origin and you can locate the complex number to be somewhere over here. Okay, this would be the presence of this complex number, negative root 3 positive I. But we are sure that the principal argument has to be found. Now in this case, if you were to see, the alpha occurs on the second quadrant, okay, but not only that, the value of alpha is going to be different. In other words, different in the sense it's going to carry a negative quantity. Now though the alpha is pi over 6 here, we cannot state the principal argument to be pi over 6, though clearly we see alpha to be as pi over 6 in this case. This is not the value. Now in this case alpha is equal to tan inverse of y over x. We cannot simply place the value of y and x here. It has to be placed within the modulus sign. Now once we place it in the modulus sign, we get the value to be as pi over 6. Now this is going to be theta. The value of theta is going to be, since the angle is found, alpha is found on the left side, and since the students, because the quantity involving the complex number has got a negative sign here, clearly the principal theta would be found on the second quadrant, and because of that we got theta to be equal to pi negative alpha. Okay, so in other words, my theta will be moving on this side. Of course my alpha will be over here, and alpha is pi over 6, and the value of theta has to be found. Theta is 180 minus pi over 6, that's going to be 30 degrees, and that will give me 150 degrees, which is nothing but 5 pi over 6. So theta is 5 pi over 6 and the magnitude is equal to 2. So this completes the solution to this question. Students, we are given this question. Z is negative root 3 negative y. We are expected to find the modulus and the principal argument. Now clearly from here, modulus of z is equal to root of negative root 3 raised to the power 2 positive negative 1 raised to the power 2. This is equal to 3 positive 1, which is equal to root of 4, which is equal to 2. So therefore the modulus of this complex number is 2. Now we have to find the alpha value. So alpha has to be found. Alpha is tan inverse of y over x. Now clearly from here we can write x to be equal to negative root 3 and y is equal to negative 1. So therefore alpha is equal to tan inverse of Now y is -1 and x is -√3. Now this goes within the modulus sign, so have that in mind. So that means this is tan inverse of 1 over √3. So this value 1 over √3 will give us, so this is going to be giving us a value of pi over 6. Now this cannot be taken to be as our principal argument. Now foremost, you have to represent the complex number on the Argan plane. So let us do that. Now when you see the complex number, it has got a negative quantity for x and a negative quantity for y. So that means you have a negative quantity for x, that means the negative side of the real axis, and a negative quantity, that means a negative part of the imaginary axis. So the complex number would be featuring over here. The amplitude, or in other words, I would say the magnitude, is given to be as 2 units. So you have to stretch from the origin 2 units. Okay, so this will be r is equal to 2. Anyway, the most important part, since I know the argument or the amplitude is present on the third quadrant, I know the value of theta is got by subtracting alpha minus pi. So alpha minus pi would give me the value of theta. So in this case, my alpha is 30 degrees and my pi is 180. So that is going to be negative 150. If I were to write it in terms of radians, it's going to be negative 5 pi over 6. So this is my principal argument. So I've got the principal argument, theta is equal to negative 5 pi over 6, and the modulus, which is 2 units. So that completes the solution for this question. However, if you want to represent theta, theta would be taken in this direction. Okay, and you can write down theta to be equal to alpha minus pi, and in the case of alpha, alpha would be featuring from here, and that completes the solution to this question. In fact, you can just place the complex number -√3 negative I is equal to z. So this is the complete solution for this question. Students were given this question, z is equal to √3 negative I. We expected to find the modulus and the principal argument. Clearly from here, the modulus is going to be root of squaring √3 and then to it adding the square of -1. This is going to be root of 3 positive 1, which is equal to root of 4, which is equal to 2. So the modulus of this complex number is 2 units. I have found that out. Now we have to use the Argand diagram or Argan plane in representing the complex number. So this is √3 negative I, so that means 3 units along the positive, √3 units along the positive side of the real axis, so that's going to be here, and -1 unit is going to be down. Since the argument, or in other words, since the magnitude is 2 units, so the complex number will be featuring somewhere over here. So r is equal to 2 units here, and let me write down the complex number. Z is equal to √3 negative I. So this will be the location of the complex number. So the complex number is located on the 4th quadrant. So that means we need to take the principal argument theta to be as negative alpha. So therefore theta is negative alpha, and we have to know what is alpha. Alpha is tan inverse of y divided by x, and x is equal to √3 here and y is equal to -1. So therefore alpha is equal to tan inverse of -1 divided by √3, but this has to go in the modulus, so that's going to be tan inverse of 1 over √3, which is pi over 6. So therefore the value, let me write down the value of alpha. Alpha is pi over 6. Okay, alpha is pi over 6. So this means theta is negative alpha, which is negative pi over 6. So you can write theta to be as negative pi over 6, which is the final answer to the question. However, you can specify the complex number by this diagram, in fact, since we are dealing with the principal arguments, you can draw the circle in a dotted fashion just to show that okay, you are dealing with the principal argument. So this is point is going to be 0, this is the modulus r, and this is theta. Okay, theta is going to be minus alpha, and that completes the result to this question.